Welcome to the Gen AI Daily Briefing for Sunday, August 16th, 2026. A useful pattern over the last 2 days is that the stack is maturing in 3 places at once: output provenance, inference efficiency, and reliability of agent execution. And in parallel, the business side is starting to look more like a real market than a frontier science prestige contest. First up, Anthropic shared more detail on how Claude's new watermarking works. The interesting part is not the press angle, it's the engineering trade-off. We're increasingly seeing a split between visible marks for user signaling and invisible provenance signals for post-hoc detection. Anthropic is leaning into the second category as the durable layer because any visible watermark is ultimately a UI affordance, not a security control. If a system allows cropping, recompression, format conversion, or downstream editing, visible marks are fragile by definition. What matters for architects is where watermarking sits in the pipeline. If it is attached at generation time, but not preserved through editing chains, it's useful for first-party products and weak for the broader content ecosystem. If it is embedded in a way that survives common transforms, it becomes part of a provenance stack alongside metadata standards and detector infrastructure. Anthropic also clarified the code question, which is important. Watermarking natural language and media has one risk profile. Watermarking executable code is a different story because any perturbation can alter semantics or developer trust. Expect the industry to keep watermarking code either out of band or metadata-based, not in-band in ways that touch the token stream. Related to that, Google is now letting users remove visible watermarks from Gemini and Flow outputs while keeping invisible identifiers. That sounds contradictory until you remember visible watermarks are mainly behavioral nudges. The bigger takeaway is that the major platforms are converging on hidden provenance as the enforceable layer and backing away from the idea that an obvious corner badge will do much in the wild. Next up, on the market side, Ars reports OpenAI and Anthropic are in an active price war as Chinese rivals gain ground. This is one of the more important business signals in the feed because it suggests the model layer is entering margin compression faster than many infrastructure investors hoped. Chinese labs have been pushing price performance hard, especially on coding, multilingual, and enterprise-friendly SKUs, and U.S. providers are responding the only way they can in the short term: cheaper inference, more bundled features, and tighter enterprise packaging. For engineering leaders, lower token prices are only half the story. The second-order effect is architecture change. When models get cheaper, teams stop over-optimizing prompt length and start spending budget on redundancy, self-checking, multi-pass retrieval, and agent loops. In other words, falling inference cost tends to increase system complexity rather than simply lower spend. The likely equilibrium is that base model calls become more commodity-like, while value pools shift upward into workflow integration, proprietary context, evaluation, and managed reliability. That connects directly to Meta's latest positioning around Glimmer. The company is talking loudly about AI being for everyone, while also keeping its more powerful Muse Spark model closed behind APIs. This is not hypocrisy so much as the new default strategy for frontier vendors: open enough to shape the ecosystem, closed enough to preserve margin and product control. Open weights win developer mindshare, accelerate fine-tuning, and create de facto standards. Closed endpoints capture usage, telemetry, and premium enterprise revenue. The strategic implication is that open versus closed is no longer a binary. It's becoming a portfolio design question. Release a strong enough open model to dominate community experimentation, then reserve the best reasoning, tool use, or multimodal stack as a managed service. Expect more labs to do exactly this, especially as enterprises increasingly ask for deployable weights for regulated workloads, but still buy premium hosted models for high-end orchestration. Worth flagging from the startup side, COG, out of France, is arguing that GPUs are not inherently a bad fit for agentic workflows. That's a useful counterpoint to the current narrative that agents imply CPU-heavy orchestration, sparse bursts, and poor accelerator utilization. Cog's thesis seems to be that the problem is less the silicon and more the runtime. Scheduling, batching, KV cache handling, and the way tool calls fragment execution. If they're right, there's a meaningful infrastructure opportunity here. Agent stacks today often look like a traffic accident between a tokenizer, a vector database, a workflow engine, and a container scheduler. If someone can make multi-step agent execution look enough like a schedulable accelerator workload, they can improve throughput without waiting for brand new chips. This is exactly the kind of boring-sounding systems work that can matter more than another benchmark point on a frontier model. On the research side, one of the more practical papers is reduced matrix multiplication, or RMM. The idea is training-free, input adaptive reduction of transformer matrix products during inference. In plain English, instead of always paying for the full multiply, the method selects informative slices along the contraction dimensions and lets you dial a retention ratio. So it's not changing weights, not retraining, and not pretending every token needs the same amount of compute. That matters because most real deployments do not want a heroic model rewrite. They want a controllable knob. If RMM holds up in production-like settings, it could become part of the inference toolbox alongside quantization, speculative decoding, and KV cache optimization. The appeal is operational. Smooth accuracy-efficiency trade-offs across models from 1 billion to 70 billion parameters. The caveat, as always, is workload sensitivity. Input adaptive methods often benchmark beautifully and then get weird on long-tail enterprise prompts. Still, this is exactly the kind of paper inference teams should be reading. Staying on latency, DAR tree is another notable paper. It pushes speculative decoding forward by combining diffusion-based drafting with autoregressive draft trees. The underlying problem is that diffusion drafters can propose many tokens in parallel, but their proposals are marginal and lose the path-dependent causal structure you want for exact verification. DAR tree tries to get the breadth of a draft tree while carrying correction information down the branches. Why care? Because speculative decoding remains one of the few levers that can deliver real user-visible latency wins without changing the serve model's outputs. If this line of work matures, the near-term beneficiary is hosted inference providers trying to shave milliseconds at scale. And unlike some compression tricks, speculative methods can improve economics while keeping fidelity guarantees, which enterprises tend to like. Now to agents, where the reliability story is getting sharper. QuoteBench is a deceptively important benchmark because it isolates failures between what a coding model intended to emit and what actually gets executed through shell and parser layers. This is a classic systems boundary problem. A model may generate the right command in spirit, but serialization, quoting, interpolation, or transport wrappers can mutate it into failure. If you only score final task success, you can misattribute the bug to the model instead of the harness. That is exactly the kind of mistake teams make when they scale coding agents too fast. They benchmark the brain, not the boundary conditions. QuoteBench is valuable because it forces a cleaner separation between generation quality and command path integrity. For engineering leaders, the lesson is simple. Treat the agent runtime as part of the model because in practice it is. In a similar vein, Vero asks a harder question. Can AI agents build formally verified software repositories, not just solve isolated proof tasks? That's a much better benchmark target than toy function-level verification. Real software has module boundaries, implementation choices that constrain proof structure, and all the brittle coupling that makes formal methods powerful but expensive. Vero is interesting because it tests whether an agent can keep implementation and proof decisions coherent across a repository. I would not read this as verified coding agents are here. They're not. but it does point toward a realistic long-term enterprise niche. High-assurance code generation and security, infrastructure, aerospace, fintech controls, and regulated environments. The value is not replacing developers. It's compressing the distance between implementation and proof. One last market note. There's also a warning that hyperscalers could regret leaning too hard on natural gas if price forecasts are right. That may sound adjacent rather than central to AI, but it is central. Inference pricing, regional capacity planning, and where training clusters land are increasingly energy market questions. Cheap models don't stay cheap if your power thesis breaks. What to watch this week? Whether pricing cuts trigger more aggressive enterprise migration between model vendors. Whether provenance standards keep converging around invisible watermarking plus metadata. And whether inference teams start adopting more training-free acceleration methods instead of waiting for the next hardware cycle. Also, keep an eye on agent benchmarks that measure system boundary failures, because that's where a lot of production disappointment still hides. That's your briefing. We'll see you tomorrow.